The reason some of the greatest snowfall totals in the United States occur near the Great Lakes is due to a meteorological phenomenon called lake effect snow. Known far too well by residents of Michigan, Ohio, Pennsylvania, and upstate New York, lake effect snow has its greatest chance of occurrence late fall into early winter. But how does this lake effect snowfall occur, and why do the chances diminish ironically as the calendar gets deeper into winter? Find out next with me, student meteorologist Dylan Godet. So how does lake effect happen? Let's start out with a little geography. Lake effect snow occurs most commonly along the Great Lakes here in the United States. Those lakes are Lake Superior, Lake Michigan, Lake Huron, Lake Erie, and Lake Ontario. Now that is a lot of water. How much water, you ask? It's the equivalent to 1/5 the world's fresh water supply. Water has a high heat capacity, which means it's able to retain a large amount of radiative energy or heat absorbed by the sun. Now what happens to lakes like this over the late summer and early fall? They become very warm and retain energy for a relatively long amount of time, especially compared to land, so that when the temperature begins to drop come late fall, the waters in the lake end up being significantly warmer than the air above it. This contrast between lake water temperature, the air above, and the land nearby is called a thermal gradient. This gradient can allow for the atmosphere to become unstable and support rising motion necessary for cloud and precipitation formation. But what other ingredients are needed to produce a lake effect snowstorm? Well, like I mentioned, you need a large body of water. You need this large body of water to provide moisture to the lower portion of the atmosphere. Next, you need winds. The winds will help the moisture flux from the lake into the air. For the Great Lakes, those winds generally come from the north and west out of Canada. Canada is a source region for our cold winter air masses. If winds are aligned with the longest axis of the lake, that could mean heavier snow bands because more water will be entrained or pulled into the lower atmosphere. The winds cannot be too strong though. Strong winds do not allow for an efficient flux of water into the lower atmosphere. Next, you need a significantly cold Arctic air mass. They are one of the key ingredients for lake effect snow. These kinds of frigid air masses usually originate in central or northern Canada. Now that we have all the ingredients, how does the lake effect snow event now form? The cold air mass works its way across the lake and the water beneath it is much warmer than the air above. So that water warms the air directly above the lake, and what does warm air do? It rises. As that warm air rises, it condenses into clouds and snowflakes since it's moving upwards away from its heat source. This process continues through the whole stretch of the lake and eventually forms a snow band, as you can see now on the radar. The wind across the lake determines where these snow bands are directed. This means an area near your location could be seeing snow rates of 2 to 3 inches per hour, and you could be seeing nothing, sometimes even sunny skies. This banding is caused by the path or distance of the air over the lake, known as fetch. The longer the path or fetch, the thicker the clouds grow and then drop snow downwind. Along each of the Great Lakes, there are locations that are optimal fetch directions. This process continues with every passing shot of Arctic air until later into winter when the lakes begin to become frozen over. This explains why later in the winter the lake effect dies off. If the lake loses the liquid availability directly under the lower atmosphere, there is no significant moisture flux into the atmosphere. There must be open water, not ice, for clouds and snow production to take off. By later winter, there's typically enough cold air around to extract more energy from the lakes, bringing the surface water below zero and then eventually freezing. Now, you start to lose some of those key ingredients, the moisture and the heat, and it becomes difficult for lake effect to occur. Lake effect snow is one of the more truly amazing weather phenomena that occur. But remember, it's actually a relatively small weather phenomenon. It takes place at a very small area, unlike a big nor'easter that covers a large swath of space. But again, it's one of the reasons I chose meteorology as my field of study. Thank you guys for watching. For more awesome content, check out the CalU Meteorology Facebook, Twitter, and Instagram pages. For awesome student content like this, check out our YouTube page at CalUWX on YouTube. Thank you guys for watching.